Hey everyone, let's dive into the science behind those impressive results from Figure 3. So we talked about how SLA violations, essentially, when a cloud service fails to meet its promised performance, were drastically reduced. But how did that happen? Let's break it down. At the core of this breakthrough is reinforcement learning, a type of AI where algorithms learn by trial and error. Think of it like a student solving math problems. They try different approaches, get feedback on what works, and gradually improve. In cloud computing, this means training systems to make smarter decisions about allocating resources, like computing power or storage, so services run smoothly without breaking their SLA promises. The researchers built on earlier work, like adaptive resource management strategies from 2017 and early reinforcement learning models from 2016. But what's new here? They combined these ideas with deep reinforcement learning, a more advanced AI technique that can handle complex, real-time decisions. Imagine a traffic system that not only reacts to congestion, but predicts it using vast amounts of data. This is the kind of proactive intelligence they're developing. Their method, tested in cloud environments, used simulations to train the system. By rewarding efficient resource allocation and penalizing delays, the AI learned to prioritize tasks in a way that minimized SLA breaches. The result? A significant drop in violations, proving that AI can make cloud services more reliable than ever. But here's the kicker. This isn't just about avoiding failures. It's about creating systems that adapt and optimize on their own, saving costs and improving user experiences. And as we'll see next, this approach has even broader applications, like predicting weather patterns from satellite data. Stay tuned. Let's take a deeper look at how this works. The team tackled a critical challenge in AI and cloud computing: SLA-aware resource allocation. SLA stands for Service Level Agreement, a contract guaranteeing specific performance metrics, like finishing a task within a set time or keeping costs under control. The goal? To create a system that dynamically adjusts resources, like GPUs and CPUs, during AI training to meet these SLA targets. Think of it like managing a kitchen during a busy dinner rush. Too few chefs, resources, and orders pile up, too many, and you're wasting money. But what if your kitchen could adapt in real time to keep things running smoothly, on time, and under budget? That's exactly what this research achieves. The system uses a framework called Markov Decision Process, MDP, which models decisions where outcomes are partly random and partly under your control. Imagine navigating a maze. At each step you choose a direction action, and based on that you either move closer to the exit reward or hit a wall penalty. In this case, the maze is the resource allocation problem, and the goal is to find the best path to meet SLA goals. The system tracks key factors in its state vector: CPU and GPU usage, task progress, and whether SLA targets are being met. Then it employs an actor-critic architecture, a type of reinforcement learning. The actor decides what actions to take, like adding GPUs or reducing CPUs, while the critic evaluates those actions to ensure they align with SLA goals. Here's the clever part: the system adapts its rewards based on user priorities. If you're focused on time, it prioritizes speed, even if it costs more. If cost is king, it minimizes resource use, even if it takes longer. For a balanced approach, it walks the line between the two. The rewards also adjust dynamically. If the system detects an SLA risk, it shifts focus to prevent breaches. This isn't just theoretical. The results show that AI can turn cloud infrastructure into a self-optimizing ecosystem, reducing failures while cutting costs. And as we'll explore next, these principles extend far beyond cloud computing, into fields like climate modeling and real-time logistics. Keep watching.